Welcome back, everyone. This is no longer the Gregorian Julian show, but we're here to talk a little bit about hybrid applications with the cloud. And if you have questions during this talk, please send them to the lovely hashtag via Twitter, and I will try to answer them as much as I can. But when you dive right into this and we talk about building applications in the cloud, or with the cloud, I should say, this ubiquitous cloud word that everybody talks about, we're particularly talking about Windows Azure. And when you build these applications, on-site, on-premise, it's pretty easy. You pretty much control everything that you have these days. But when you start doing applications that interact with this cloud, and most every application today that you can think of, because we carry around these computers with us everywhere we go, has some component that interacts with the cloud. So even if you have something that's local on-premise, even say if it's in your pocket versus in your data center, you probably have some components you want to have take advantage of this cloud. And when I talk about hybrids and cloud hosted and on-premises, this is kind of what I mean. So you can think about a typical application. You got an enterprise that runs and has a bunch of applications that run their benefits, their vendors, their CRM, their accounts, and then you may want to take some advantage of some elasticity or not have some way to get, you don't want to expose your whole data center to the world, and you want to put something up in the cloud that's hosted, or even if you do it through your own data center, you want to expose that to the cloud. So you may have things running up there that's like your shopping carts or your shop application that you have, as well as your travel application, those type of things. So that's when we talk about this hybrid approach that we're going to discuss. That's what we're going to talk about, these cloud-hosted parts and these on-premises parts of your application. And really what this whole talk is going to kind of center around is something that we've done here at Patterns and Practices. If you've kind of followed along with us in our little cloud journey, we've done a few books on cloud applications where we talked about kind of getting you up and running and moving your applications to the cloud, developing kind of greenfield applications for this cloud. And now we're kind of doing this approach where you have applications that you have on site and you have running in the cloud, and parts of it are running in both places. And then you can, and what we're going to talk about today is this fictitious company called Trey Research. And they have this application that they want to do exactly that. They have parts of their application they want to take advantage of the cloud by taking advantage of the elasticity and the scalability of the cloud, but still have all of that interop with all their on-premise applications that they don't want to move. Basically, maybe they don't want to move their CRM data. They don't want to, for privacy reasons, they don't want to move all of the pieces up to the cloud. So today, Trey Research looks like this. It's a pretty typical application. Maybe it's atypical, depending on what you do. They're kind of an order fulfillment center. They manufacture parts. They're based out of Chicago, Illinois. Go Chicago. Then say, all right, we have people that transport out all of our parts that send them once people place their order. They have an order application that people place their orders through. They can do it any way, through any device. It's a web application. They have a bunch of databases that they hold all their customer information in, their product information in. They have their management part of their applications. They have this other piece of the application, this compliance application that says, if I have something over an order of $10,000, that I'm going to make sure that that person has the right credit check and all this stuff. And that's kind of a legacy app, the third-party app that they bought. And they also do reporting through SQL Server. And they have all across their applications, they do the same thing, which is they manage and monitor all these applications. And you can imagine that I'm just centering around this orders application, but there's multiple applications that accesses this data. There's multiple applications that are involved with this application. And they also, involve their transport partners where they have to say, once an order gets placed, I want to be able to send that out and say, all right, depending on where they're at and how they do it, I may want to send it out through some, the big brown guys or the FedEx guys and other partners that we may interact with to actually ship out these parts that once we're done with them, or once the people have actually placed that order. And what they really want to go to is, and you're like, oh my God, I just exploded all over the screen. And I know this kind of looks big, but if you think about the architecture that they're going towards, this is what they're looking at. So we're going to move that whole orders applications up into the cloud. We're going to have to move some of the data up into the cloud. We're going to have to move that, we want to have all those components that deal with the orders application close to as possible to the application itself that's running in the cloud. And when we're talking about the cloud, we're again talking about Windows Azure. And we want to be able to still be able to do authentication. We still want to be able to interact with all the things that are running on premise down here at the head office. We still want to interact with transport partners. We still want to have these partners be able to access the reports that they have. We also want to make sure that we can scale out this application and run in multiple data centers. And by doing this, we also kind of want to change some things around in our application. Before, we had maybe some forms auth authentication where they authenticated against orders application, but now we want to support some social type of identity providers where you can log in through Live ID or Google or Facebook or whatever you want to do, or even through the forms auth that we have today. So when you think about going from what I looked at, that small application, if you think about it, it really does look like this, but now we're kind of blowing it out and looking at it, how it would run in the cloud and in the local data center. And what they can, by doing this kind of overall architecture, they can look at in all these little places, where can we use Windows Azure? Windows Azure to actually go into and take advantage of Windows Azure to actually be able to do what we just saw in the previous slide, which was build out this architecture of an application running on-premise and in the cloud. And you can see there's a lot of things that we can use that's part of Windows Azure to help us in kind of moving this application, the orders application to the cloud, but still be able to communicate back to the head office, still be able to kind of work seamlessly the exact same we did when we were all running it in our data center. And when I say we, I mean Trey Research. So I'm going to give you a quick demo of Trey Research. I've already got it running here. And this is the actual application that we ship with. It's kind of a application-ish. Probably you would not just want to ship this on the for yourself, but it does have a lot of things in it. I'm also going to run this little transport partner simulation so that I can kind of show you how this all works. And this is just a little WinForms app that actually shows you how you can do this. And I'm going to go back to over here. I'm going to log into this application. And again, what we've done is we've actually gone in and you can see this. We've actually gone in and using Windows Azure ACS, Access Control Service, we've actually gone and said provisioned that you can log in with Live ID, Google, Yahoo. I'm going to choose my Live ID. And all of you can make fun of my awesome Geek Boy. If you want to contact me, this is another way, geekboy@hotmail.com. I've had this for many, many years because I am a geek. At least that's what my kids tell me. And I am a boy, at least today. And I can go in and I can start looking and browsing around in the store. Now that I've kind of gone in here, I can get this bypass filter. I'm going to add it to my cart. And I'm going to go ahead and check out. And again, never checked out before, so we don't have any information about me. So I'm going to give them, whoops, just kidding, that's my email address. This is me. This is me. I'm going to say somewhere in Redmond. I used to live in Alabama, but I don't anymore, for all those that know me. I'm in USA, and the interesting thing that we'll notice later is that there's two, I showed you that you saw that there was two transport partners, and the reason for that was, you guys want to call me, go ahead, if you can write that number down fast enough. I'm going to go ahead and submit my order, but when I do this, I submit this order, you can see, hopefully I got the right guy up here, that eventually we will have, I also want to go over here and open up Contoso as well. If all things, there he is. That you see that I got my order submitted, and I have my breakpoint here for this later demo that I'm going to show you. But I wanted to show you, let me go ahead and play past this. That I've got this order submitted, and you can see my order ID here. This actually order went out, got submitted into the orders application, got a message over to my transport partner, who is this guy right here, that I need to go out and deliver this message, and then I can go in as a customer and review all my orders, and you can see where it's been updated, those type of things, that the order was received. It's going to be placed out for shipment once I get an acknowledgement back from the shipping partner, and it'll be kind of like this whole interactive things that I can do with my customers running out in Windows Azure. Right now I'm running locally in my emulator, but you can see how this all works out. So that is the application. I'm going to go on. And here I want to talk about today a little bit of the challenges that you can have when doing something like this. So you saw the picture where I went from this little small application, I blew this up, it went into this big, huge thing. You were like, holy crap, what have I just got myself into? Well, really, it's not that hard. If you think about breaking this down into these smaller chunks, it's really not that difficult to think about and do to move these things. But there are challenges with this, where we talk about deploying the app to the cloud. We talk about how to choose the right communications of getting back and forth through the cloud, how to optimize things when running in the cloud, especially this order process that I just showed you, where we're talking to transport partners. We've got things running in multiple data centers. How do I synchronize all this information? Then the non-tangible things, like how do I make sure that it is scalable, it is performant? I could always tune things and buy more hardware and do those things when I was running in on-premise, but how do I do that when it's running up in the cloud? I don't own any of this stuff. How do I give an authentication scheme? How do I change that from what's to do it? And how do I still manage and monitor all the applications that are running on-premise and in the cloud, but look at them ubiquitously like I was before, like if I had System Center or something like that running? How do I keep doing those things? And again, this is not all inclusive of the guide that we have. I definitely, at the end of the talk, I'll show you where you can go get the guide and resources for the guide. There's a lot more information in there, but I just want to cover these big topics today. So deploying Orders app and data. So when you think about the application, what we had before, we had a small web app that, I should say small or big web app, depending on your size of your business, running, and we had it talking to multiple databases. It needed customer information, it needed to place orders, it needed product information. And how do I get all that stuff? When you break that down, what are the things that I actually need to move to the cloud? Because you remember, it also talked to this, compliance application that made sure that if I had something over $10,000, I wasn't going to, I could run a credit check, and maybe we place that order on hold before while that credit check was run, and then we can come back and then actually fulfill that order. And what are the things that I actually move to the cloud, and how do I keep them consistent when I do move to the cloud? So let's talk about the app and the data itself. So if you look at the big picture now, we have moved the orders application, the compliance application, some of the business logics running up in the cloud, the authentication, and all those good things. But I've got these pieces, which are the data itself, where I have customers and product data. I've got order data. I may want to run those in multiple data centers. I have the application itself. How do I do that? So especially when you think about running across multiple data centers, but I also here at the head office still have the customers and products database data, because the product application, the kind of what products we make and what products we ship and all about the products come from a different system than the orders application. So if I get all that product data, how do I get it up into the cloud next to my order application? Because I don't want this chattiness going across the wire and doing all this stuff. So one of the ways we can do this, because we're using SQL Azure and SQL Server, is we can use what they call SQL Data Sync. And SQL Data Sync is love. You see my little heart picture here. It's all about the love here. But I can actually sync this data using SQL Azure Data Sync to have replication, just like you did with SQL Server before, and have this product and customer database synchronization go back and forth. Products is a pretty easy one. It's a one-way sync. You can imagine I'm not managing products up in here in the cloud. I'm really managing it all over here on premise. So I can just one-way sync my data up to the cloud, and then I can actually go in and say, all right, one-way sync this every 10 minutes or every 20 minutes or maybe every day, depending on how often I come up with new products. Real quick question, the sample Visual Studio solution be available for download? It is available for download. If you wait till, I will have a pointer to the end, but always, if you ever want to know, you can go to msdn.com/practices, and that's where Patterns and Practices, all our content lives, and you can go find this. I just think we released this a few weeks ago, so it's available, and it's available for the download, and there's also a Codeplex site where you can go talk about it in discussion groups that we participate in, that we can always we take your feedback, and anytime we make improvements, we always look at that feedback to get it back into the application. So the customer's database is a little bit different. So you can imagine, if you saw me, I registered on the actual website. I might have existing customer data that I still take call-in, applications and have people order via the phone, So I have this two disparate databases that have the same information in it. But I can actually set up SQL Azure to do the same thing, where I can say, all right, I want you to using SQL Azure Sync, I can sync between customers and have it be a two-way sync. So new customer data gets pulled down into my on-premise database, and new customer or other customer information up there gets pushed up into there. Now, it may not have a social identity associated with it because, we've just given them some stuff, but that will get filled out and eventually moved back down into my head office. So I can keep these two things in sync. But the orders is actually a little bit more complicated, because you imagine the orders database only lives in the cloud. So there's no right way here. Again, we're not making any mistakes. They're just happy accidents that happen, and we stumbled across one of them. That's one of the challenges. Like, if I have these databases in the cloud, how can I do that? I could use SQL Azure Sync or something like that and come up with my own. Then I have to come up with a schema for how do I manage identity, like this order ID is this order ID, and make sure they only have certain ones. But another possible way of doing that is using Service Bus. And I can use Service Bus topics and queues to actually go in and say, all right, instead of me actually saving data to a database, I could actually set up topics and queues that I send the actual messages to. And I think if you were in our previous if you saw the previous stuff with Grigori and Julian, when we were talking about when they were talking about CQRS, this is something a little bit similar, where we have the application only querying data off the orders, but whenever it places an order, it doesn't actually write it to the database. It goes off and sends that to a queue. That queue can then be set up to say, all right, depending on where the order was placed and how it all, I'm going to put this message on a queue. I'm then going to have a receiver that sits up in all the data centers, pick off those things from the queues, and say, all right, I'm going to take that data and push it into my actual orders database, so I can keep them consistent across all my data centers. And again, this is only one way of doing this. If you go get the guide, you will definitely see that we have a lot of different options. One of the things that we try to do in these guides that is not just give you the one way of doing things, but here is the choice that we made based on all the constraints that we had for this particular application. But there's also other ways you could solve this exact same problem and still come out with a good result. So you can see that data synchronization for the Orders app is a little bit different, but still absolutely doable. So talking about data and synchronization and Service Bus and those type of things, we've got the Orders app up in the cloud. We've kind of made it available and got it working and kind of synchronizing to all the different aspects. But we also have this compliance application. We still have to talk to our transport partners, and we still have some other communication mechanisms that we have to deal with. And one of the things you have to think about is, how do I want to communicate with within all these different things? How do I want to communicate back on premise? How do I want to communicate with partners? Those type of things. And there's a kind of a spectrum of communication when you talk about Windows Azure, and there are easy things to do all the way up to easy, but I wouldn't say as easy as the left end of the spectrum here. If I'm looking at it, it's much more easier to but I can get much more reliability out of service queues and topics than I can Azure Connect. Azure Connect is basically builds your own virtual private network with your on-premise data center with the Windows Azure data center. I can do relays that are simple messaging back and forth between wherever I decide to set up the relays, and queues and topics, which we saw a little bit of before. So queues and topics are really reliable. They can be secure. They can be really easy to set up, whereas Azure Connect is more of I have to have a dedicated domain controller, a dedicated kind of virtual private network. Easy to set up, and we talked through that in the guide, but probably less reliable because you're relying on that internet connection always staying up. So you have to think about these things when running through your application. What can I reliably not have when I'm running the Orders application? So if you think about it, I can reliably probably not have connections back to get cut, or I cannot have my customer data not be there. I cannot have the product data not be there. So that's why we moved all that stuff up there. But I can probably be okay with having my compliance application be offline for a little bit and having that status checked every once in a while so that it can talk back and forth between what it needs on the on-premise site and the off-premise, so that I can still have it work, but it may need some data on the on-premise. I can have that virtual private network set up, so if that goes down, having that be down for a day may be okay. Just know that, connections are not always reliable, but you want something a little more reliable, you may want to go to queues and topics. So in the big picture again, back at looking at Tray Research and how they solved this, moving their orders application up into the cloud, these are the bigger things that you can look at. You can see that we took the compliance application, we use Azure Connect so they can have the reports and monitoring for that actual piece be a virtual private network back to their own data center, because that VM, the actual compliance application, needs to be its own Windows Server box, so it has to be running a VM role. We can use Service Bus queues to actually talk back and forth to our transport partners. We can use the Service Bus Relay so we can have external partners actually get access to those SQL Azure reports without us actually putting it out onto the internet from our own, or putting it behind some DMZ in our own data center. We also use topics and queues to kind of work through some of this, how we place orders and how we manage those orders, again, back and forth between data centers. And I'm going to show you in just a little bit of something called a supervisor pattern, where we kind of optimize that order process. So one of the great things about using Service Bus, topics, and queues is that it gives you the ability to secure them. Now, again, when we talk a little bit later about authenticating users and how we can get those users, the social identities and associate those users with social identities. Service Bus uses that same technology to secure your messages. And one of the things that we do when you saw me kind of go through that order came up over on the transport partner, and we are using Service Bus topics and queues to actually send that message back and forth between the transport partners. And if I told you there was a Chicago part to this, or that the company's located in Chicago, I kind of made mine in my transport partner be in Washington, or my order come from Washington or shipping to Washington, and they're in Chicago. They actually have deals with different transport partners, and one of them is a local guy, and the way he connects to, he actually connects to Service Bus rather than talking about building an adapter, and I'll talk about that in a minute. But that whole communication between our transport partners and our actual application is done using messages, and we want to make sure that when any of these messages go back and forth, they're secure. So what you do when you create a Service Bus queue, that actually, or a Service Bus namespace, it actually goes ahead and creates an ACS namespace along with it, so that you can use that to actually secure the edges. And when I say edges, I mean like the actual endpoints of the application or the Service Bus with ACS. And what I can do is I go out to, when I go out to go send a message, I can go out to ACS, I get a token from ACS because it authenticates me. I take that token, and then from there, I can then say, all right, go talk to Windows Azure Service Bus. And Azure Service Bus says, yeah, I've got that actual, or that token is actually valid. I can give you the message and give you that back. And then that way you can be assured that you're actually secure. One of the other things you can actually do is, even at the level of the message, you can attach and wrap that message with that ACS token, so that your application can then validate that token. Now, that's not something that we actually showed in the project. We don't actually, that's not on by default or something done by default by Service Bus, but we actually show you how to do that. So another good question out here. Antonio asked, what would be recommended for high reliability and high responsiveness? Azure Connect or Service Bus queues? I would say Service Bus queues. That would be the better. Azure Connect is definitely something that you would have to make sure that your internet connection stays up between your local on-premise versus your VM, the VM or that's running in Windows Azure itself. So you've kind of created that virtual private network, and if that connection gets, like your connection goes down or your connection goes down, that becomes unreliable. But when you're talking about Service Bus and queues, you can think of it as a kind of a producer-consumer queue. You can place things, any client can place, whether it's running in Windows Azure or outside Windows Azure, can place a message on the queue. That thing will be there for a set number. I think 7 days is by default. They always change this, so You have to look up the correct documentation. I think the last time I looked, it was like 7 days. It will be there. It can stay there, and you can give it, I think, another timeout. And so you can pull that message off anytime you want to within that 7 days, whether it be from Windows Azure or from outside Windows Azure. So that's a good question. So moving on. So I want to talk a little bit about, and I've kind of mentioned this optimizing the order process. And this is a little bit of a topic that we got from Clemens Vasters. This is something that, if you think about it, makes sense from the order perspective is, if I have an order that's placed, how do I make sure that order is placed? I don't want to, because what happens if my database connection is faulty? How do I make sure that actually got put into the database? How do I make sure that the actual scope of that order includes I got a message out to the transport partner for delivery? Because if you think about the overall scope of what it takes to place an order, I want to make sure that all those pieces get done, because it's not just inserting a record into the database. It's actually, I need to insert the record into the database. I need to set up some way to charge the actual customer. I also need to send an actual piece of data over to the transport partner saying, hey, I've got this item you need to pick up and deliver to a certain address. So that whole process is actually about placing the order. And something we thought about is, how do we make sure that that's kind of fault tolerant? And so that at one point, if any of those pieces fail, they actually can be restarted or retried or picked back up, and all that process can complete. Well, again, we've kind of drilled down into the application. This is one of the ways that we can do this. One of the things that I talked about a little bit and mentioned was, we have 2 transport partners in this application. Now, you could have multiple transport partners. I mean, and you can imagine that I can make deals with all kinds of people to actually get this. But one of the things that we did was kind of show 2 different ways to solve this problem. And I think either one will actually kind of scale to all the different ones. But when we talk about the actual order itself and it coming in, we want to make sure that order message comes in, it gets put on a service bus topic. But think about, where should I, one of the pieces is, where should I put this to be delivered? So our one deal is with this local transport partner that actually says, all right, I will deliver in the Chicago area, or the Illinois and neighboring area, I should say. And the other transport partner says, I will deliver everywhere else worldwide. So if I'm ordering from Argentina and place an order, I will go with that guy. If I'm ordering from Naperville, which is a suburb of Illinois, I can get delivered there. So I say, all right, if I place that order, one of the things that you can do is set up these filters within your service bus topic, and it's not a rules engine per se, but it is a way to simply look into that message and look at some of the properties of that message and say, all right, based on this, I can send this message to a particular subscription, and so that only that person gets it. Because you can imagine, I might have, if I have multiple transport partners, I don't want them all picking up the same messages or the first one winning. That may be what we want to do, but in this scenario, we want to go, all right, this message is going to this partner, this message is going to this partner, and we want to make sure that gets routed to the right partner. So what we've done is we kind of set up these location-based filters, and you can do this with the service bus topics and say, all right, if you're inside this zip code, then, or within this boundary, you will go to partner B. But if you're not, you go to partner A. And you can imagine the same thing. I could keep adding on these filters and have partner C, partner D, partner E. And what we've done is, in our the 2 different scenarios, is for partner A and partner C, those guys are big corporations like FedEx, UPS, DHL. And they're not going to talk to our little service bus queue and ask and give us and take messages from us and pull them off a queue and do those stuff. You might be able to talk them into it, but I highly doubt it. For that case, we build these little adapters at the end of these that's running in our application at these end of these that actually sends off messages to their web service and basically updates us to say we sent that message. And in a second, we'll talk through that whole process of how that works. But the other side is the little local guy that we have that delivers to Illinois, Chicago and the neighboring areas. He actually will. We kind of let him connect to the service bus subscription and pull his own messages out so that he's, because he's pretty technically advanced and can seem to do all these things, and we help him out a little bit with that. This is the guy that we can actually say, all right, you can connect to this endpoint using ACS. We'll give you a token, and then you can actually pull these messages off. They're secure. We've actually encrypted with that token so that you can pull it off, decrypt it with your token, and if you push us back a message up, we use this token, we'll decrypt it, all those good things, and make that a really secure process. That way, but by doing that, showing these two different kind of ways of solving this problem, you can see how you can use these filters to go to the correct place and then use the endpoints of how to push either another, take that message and process it and push it onto another web service, or just have someone pull that message directly off and act on it and talk back to yours using a secure mechanism. So I mentioned this whole order retry supervisor pattern thing. So I'm going to walk through it and then I'm going to show you a little bit of code about how it's working. It's a big walkthrough, but the code's actually not that difficult to actually work, to make this work. But you can imagine when I actually have this whole concert of things working, I want to make sure that when I place a new order, I go and update and put that record into the orders database, and it's kind of a one-step relationship, and put a job in that says, here's the status of where we're at in this job. Because you imagine that whole concert of things that happen we call that a job. And so I've put this order in, its ID is 154, I've given the address, all the metadata around what the actual order is. I've created a job status about, is this thing locked? Anybody working on it? What stage is it in? What's the timeout on this guy? So maybe what would happen is if it got put into a state, it got halfway done, but then died, maybe I want to then have somebody else come pick up and start this job over again. So we put these two, we start this job status, we actually put the order in the database. We have a worker rule, and I'll tell you a little bit about, I'll show you this code in just a minute. We have a scheduler that basically goes out and gets this record out of the job status table and says, all right, I am now working on this. It's not processed, but I'm going to go get, I'm going to go get the all non-processed stuff and anything that doesn't have that has a timeout on it or anything else like that. And I'm basically going to go, all right, give me this data, and I will start working on it. And once he starts working on it, he sends that new order message to the topics. Again, that was back previous slide, where we send off that message saying, okay, you need to ship this or whatever needs to happen. We send that basically new order message off. Then I update, the worker role updates the record with I sent a request, and I think you saw that in my demo where it said like request sent. Then once I get a reply back on the service bus queue, I will then say, all right, I got the worker role goes, I got an order, I got it and I received it, and then he will update the record saying request received. So you can imagine if he sent it off to the transport partner that's in neighboring Illinois, that he will wait for saying he got something back until we push it back until that guy pushes back a message to him. But if we're using the adapter pattern where we're just adapting that web service from the bigger transport partners, we'll just send the request and then automatically put another message back in saying, hey, we sent it, and that guy will get it received and he'll update that with a request. So this whole concert of things that are happening, at any point, some of these things could fail. Maybe the service bus topic was full and he couldn't, or because nobody's pulling off messages from the local transport partner. Maybe they went down and we've filled up the message queue and we can't put any more messages on it. So he times out, can't put anything with it. He never got a request sent, but he never updated it, so that thing looks like it's not processed. And what will happen is that timeout will eventually happen and he'll pick it back up. But there's this guy also working called the supervisor who checks out all those guys, the failed and if something failed or the timeout happens, and he is always looking to restart all these things. And he says, all right, your timeouts happen, so you can start, I'm going to start you back over. I'm going to try and pick you up at where you left off. And I will put that message or that status in there so that when the worker scheduler starts back up, he will then say, all right, let's move on, take this guy, and I need to send out that message again, or I need to go look for a reply because I never got one, or whatever the stage of the whole life cycle that it's in. So I want to quickly show you that code. Is it looks looks daunting, but it's not as bad as you think. I'm going to stop running the app real quick. There's my stop button. All right. So we have, again, this workers role, and again, it's not a big lot of code, but we have this the status update job and the new order job. And if you look at the new order job, it's just what we call an iJob, so that we can kind of create a list of these jobs and have them run off as tasks. This is one of the trade-offs you can make, is saying, do I want to run each job have its own worker role, or do I want to run multiple jobs within the worker role? If you run multiple jobs within a worker role, just know that, and I use this term job because that's the way we looked at it, but if you run these multiple threads in a worker role, remember that they could die and you may need to restart them. So you can use the task parallel library to help you out with that, and that's what we do a lot of here in our code. But you can see that whenever this guy runs, he's just going to keep running it and get all the information about the service bus that he's in. Let me get this guy out of the way. And he's going to create a service bus topic. He's going to create a new message, new order message sender, and he's going to execute this guy. And if we look at this guy, he's going to look for the batch ID, which he goes out and tries to batch up a bunch of messages all at once. So he goes and says, give me a bunch of not processed stuff all at once, and starts getting those orders to process, and goes through and says, make sure they're not locked. If the order process expired, we ignore it. And he used the filtering subscription to actually, whoops, let me get to this right here, to go out, create a new order, and put it into the right topic. And again, he says, we just use the transport partner name here. You could use all kinds of interesting things to figure out how to filter where your things are going to go. He gets that guy, the order ID, puts it in there, transport partner name, and then sends the actual message to the queue. And that's really that part of the process. And then that's that new order job. That's really the scheduler and doing all the work itself. This status update job actually goes through, looks for orders, and this is the guy that kind of looks for messages that got received, and he's kind of listening on the service bus topic, looking for that message that can be received, and also restarting anything that needs to be restarted. And this is, again, not a whole lot of code. You can see there's probably 180 lines in this guy. Some of this is validating that token. This is really how he validates the token coming back from the local transport partner. He's also, he's talking to the receive, and he's processing the messages off the receive guy. And these two jobs kind of coordinate all the things working in concert to do all the work for the worker role that kind of does all this order processing and making sure that it happens. And it's reliable, and it's repeatable, and it all happens in concert, because again, we're not just, it's transactional, but there's no transactional boundary, because there's no real way to transact across queues and messages and your database. So not a whole lot of code, seemed a lot, but that's breaking down how you can kind of do this. And you can imagine applying this kind of pattern, the supervisor pattern, to a lot of interesting things that you may do in your application. This is just one of the places that we wanted to kind of bring it together to show you how you could do that. So once we've got kind of the functional requirements down of, the orders are being placed, we've got all the data in the right place, we've got everything next to each other, we've got a secure mechanism and secure communications, we can communicate, we've got the communications back up with the transport partners, back to our head office. We can start thinking about these non-functional requirements, scalability, performance, and availability, because we want our stuff to be fast, we want it to be available, and we want it to be performant. And one of the things that you get by moving to the cloud, and this is the whole promise of the cloud, is this scale on demand. I want to be able to look at things, and I'm not going to spend a whole lot of time on this because I think Grigori and Julian covered it very well this morning, is this whole scale on demand is saying, I want to be able to say, all right, at certain times and at certain places, I know that I don't have to have this order application up. maybe I'm running in the US North data center at 2 o'clock in the morning. I'm not going to be running a whole lot because I've got the Asia data center that's running and the Europe data center is running. So all these guys are handling. So I may want to scale up and down my instances. And I want to be able to do that on some time-based or some kind of rule-based system to do that. Well, to do that, again, if you want to use it, Wasabi is probably the right answer, because in Windows Azure itself, there's nothing that exists to do that. But Wasabi is one good tool to actually help you do those things. Another question from the audience. So Bob Baker, I actually think I know this guy. In my orchestrated experience, testing verification of things like adapter is the hard part. Can you talk a little to that? So testing adapters is a little bit hard. The reason we build adapters, and I don't want to spend a whole lot of time talking about the adapter pattern, but we want to basically abstract away the system that we're talking to. So if you think about it, if you've ever had a third-party library, you wanted to build an adapter because you're afraid, you may want to swap that out eventually, or something like that. If you think about something you use like in Hibernate, it's an adapter for all these different data sources that you could be talking to. And one of the things that makes it hard testing is because you're not testing the real thing. But testing the real thing is two separate kind of testing. I, as a developer, want to test, just the fact that my adapter returns it. I'm assuming I want to be able to put that adapter in situations that I assume that good data comes back or bad data comes back, and what does my code and how does it react in those situations. But from an integration testing, when I turn the actual adapter on and it's actually talking to the web service, that's when I can start doing things. Another hard part about that is, and I'm pretty sure I'm not giving you a concrete answer, Bob, but is that sometimes you have to work with those other vendors to go, hey, do you have a test system that I can talk to? So if you, for example, if I'm talking to FedEx and I want to work with them, do they have a test system that I can set up so I can send it dummy messages and they're not actually going to fulfill those orders? So there's a lot of things you need to think about through that process, because I think there's two sides to that story. There's the guy that's actually building the system that wants to get the actual data around and say, all right, I just want to be able to make sure that if I get, I expect this response back or this other type of response back, I can test that. But if not, I can then go and do integration testing and actually do the right thing back and forth and see if there's anything that I missed. So I'm not going to talk a lot about Wasabi, but you already heard about that from Grigori and Julian. If you didn't, go watch it if you're not with us live. Another thing that you can use to do performance and scaling is Windows Azure caching. Now, Windows Azure caching is very similar to Windows Server caching. Yes, we have App Fabric in Windows App Fabric. I think they still call it that. Caching that you can actually use, and by doing that, you can actually have some other good things. So that products was a one-way sync. You could actually store your products and pull your products into your cache. So maybe when you're dealing with customer or product data, you can go pull it out of your cache instead of actually having to go to the database and read that each time. So you're not burning that disk I/O. And again, we have three different kind of, Windows Azure Caching supports these three different types. You can use your session state just like you had before from Windows, from ASP. You have your kind of a shared local cache where that's kind of local to your application, so you get better latency. Or you could have this data source cache that is backed by a file system that actually you can talk to from many different clients. So there's different ways you can do that, but by doing that in the tray research, what we did was actually customers and products was a good one for doing that with, because products is kind of something you don't update that often, and you could put that into a cache and it can be done unless you're changing your prices daily based on the price of lead or something like that. But those type of things we kind of were able to do with in tray research. Another good one is Traffic Manager. If you remember way back in the beginning when I showed you the big picture, you want to be able to go to multiple data centers, and you may want to set up multiple data centers for failover as well. And what you can do is kind of have this DNS server lookup. Azure provides this Traffic Manager, which is almost like DNS server lookup. And when you come in and say, I'm going to www.trayresearch.com or ordersapp.trayresearch.trafficmanager, whatever your link is to your actual application, you can have Traffic Manager go in and look up and say, what should I resolve this to? So I can say look up store.treyresearch.net. That returns the actual traffic manager application URL. That goes off and says, all right, I'm gonna resolve that URL, the orders app, Trey Research, to a actual data center that I'm going to send them to. And it can also kind of not only do that for performance for requesting to the closest data center. It can also be done for failover. Again, I can set up Traffic Manager to kind of monitor my application and ping it for a heartbeat and say, all right, every once in a while I want you to go ping that guy, and when you come back, if you get something back, not a 500 or a 404, I can then say, all right, good. You're still good. Or I can just say, I'm going to take him out of the rotation, and he is he's not going to get anybody until I get a good heartbeat back from him. And also, I can load balance these requests so I can send them to different data centers depending on all the, maybe I think there's a couple of data centers in actually the US. I could send them to different ones based on, the fact that this request goes here, this request goes there. And it supports those scenarios. And we talk a lot about that in the book. It's hard to set up actually in this kind of environment, but we do talk you through how to do that and set that up in the book. So one of the last things I want to talk about as well is authenticating users. If you've ever heard me talk before, I've talked about this topic many times. It's one of my favorite topics, and it's using Windows Azure ACS, Access Control Service, and it allows you to actually kind of get rid of this whole idea of authentication in your application, and it does all the work for you. You can do multiple social identities, things like that. And if you look at how authentication is done in Trey Research, we have this idea of the corporate people that can log in. We have the idea of the customers who can log in with their social identities. And if you look at it, we set up ACS to kind of trust both these guys. And ACS acts like a middleman, and he says, all right, once the customer comes here and he picks how he wants to log in, I will redirect them over to the right place, whether it be Google or Facebook or your corporate STS. Because like when I try to log in at Microsoft and I'm outside of the corporate domain, it'll throw me over to this page and it says, what is your credential? Are you, corpsts.microsoft.com? And I log in through that, and then I'm in. And it's the same way with Google or Yahoo or anybody else. And then the actual order application can then use that user. But one caveat that I will tell you about when doing this is, unfortunately, each ACS instance is tied to a data center. So when you do something like this, and you talked about Trey Research, you had to say, all right, if I have Scott Dinsmore at US Data Center 1 and the Asia Data Center Scott Dinsmore, their actual tokens for ACS are going to be different. It's one caveat that we talk about a lot about in the book that you have to think about, because you'll have to have a way to merge that when we talk about data synchronization back together to say, this is Scott Dinsmore, this is Scott Dinsmore, all right, let's put them together and give them the same token for this, or these two tokens assigned to the same people so that when we sync them back together, they can still be used. And the last thing I want to talk about today is monitoring and management. And real quick, Bob also asks again, can you have multiple schedule worker roles per instance, like multiple Unix or Windows service processes? And the answer is yes, you can have. If you look at the way we did it, we did have multiple workers in the same worker role. Worker role is just a encapsulation. Just think of it as a big Windows run loop. And you just say, while true, execute whatever the heck you want. And you could have multiple threads falling off into the same, or flowing off and doing multiple things. You can do however you want. If you looked at how we did it, we actually created a task for each job, each thing, and each task ran in its own, and we let the task scheduler decide if it's a thread or however it wanted to do these tasks, and let them run off on their own. Now you could, if you needed, the isolation, you could have one worker role just do one thing, and that'd be great for you. So one of the last things we put into Trey Research is I want to be able to still kind of have this ubiquitous management of my application. And the way we can do that is there's lots of features in Windows Azure that still allow you to kind of collect all that log data, pull it back into your main application, actually have all the Windows Azure diagnostics. We use the enterprise library logging block to actually log all this data to diagnostics. We can have our own log data if we wanted to, but we actually use all of the Azure diagnostics to where you saw those trace helper in the code earlier in the talk. That's actually going all out to Windows Azure Diagnostics, and we can actually set that up. and then pull that down. And we actually have an application within, and I'll show you that real quick because we have a couple more minutes. We have this, whoops, if I can find it, orders website, orders shared, head office. Almost too many for me. Let's go to debug, start new instance. But this head office application is actually the one running. It just runs locally here on my machine. It's not using Azure or anything, but it actually connects up to oh, and I bet you have to run the other one too. And since I'm not, it's not going to work. Oh no, there it is. I can actually go in and it allows me to kind of mess with products so that I can turn on data sync and do all those other things. But I can also go get the audit log and diagnostics log and pull that data down for my application. And behind the scenes, we'd show you the code that actually pulls all that management data down. You'd probably want to run that as a service that can pull that data down, or you can use System Management Center. I know they have features in there that'll pull this diagnostics data down and make it part of your overall management strategy. But if you had something on your own homegrown thing, which a lot of people do, you could do all this for audit logs and diagnostics logs and pull all that together and collate that data down locally at your head office and still be able to view your world like that application was still running in your data center. Whoops, just kidding. There we go. So that's pretty much monitoring, so that I can still kind of do all that, guys. If I could use SQL Azure Data Sync, or I could do that, pulling that data down myself and pull all that together, still use it to monitor all my applications. So, kind of what we've covered today, the whirlwind tour. I know that went really fast. It did for me, at least. Hopefully you guys didn't get too bored. Was we kind of talked about how Trey Research talked about moving parts of that application to the cloud, Windows Azure, how they picked and choose what pieces they wanted to deploy, what components they deployed, how they chose the right communication technology for the pieces that they did deploy, and how they still wanted to talk to all their partners and back to the head office, how they prepared for the failure of things running up in the cloud, how they used, again, we use Wasabi here to scale on demand. We use even some of the features of Topaz, which is kind of this retry block. How we gave a better user authentication experience besides just what they had. And then we also showed you kind of how we could still use our management to provide a centralized view of all the systems running in there to kind of pull that data down from our cloud application and still get a centralized view of that. So I wanted to talk a little bit about all the resources kind of that you can go to and find and use to get these guys. So we do have a Codeplex site. This is the place where if you have feedback or want to know more about the actual project, this covers actually every single project that we've done on Windows Azure. WAG, Windows Azure Guidance, for all those that wanted to know what that little acronym stood for. On Codeplex, you can go to the discussion forums. We'll answer questions there. If you want to go directly to the hybrid application, that is the crazy URL. I probably should have used a URL shortener, but I didn't. Again, like I said before, if you ever have questions about wanting to know more about our patterns and practices, that is where you can go always and find our latest content. You can find our full catalog of everything that we do. And if you're interested in what I talked about for that scheduler agent supervisor pattern, that is actually, Clemens Vaster, who wrote the foreword for the book, who's kind of the guru in the service bus technology and Azure technology, I should say. He helped us out a lot there, and he actually wrote up a whole blog post about this, and we actually went in through and implemented it. And I know John Smith looks like he's asking questions that I can't read on the little screen because I'm blind, I'm old. Oh, never mind. So I appreciate all you guys coming out today, and appreciate anybody that downloads the video and watches it later. It was a great talk. Hopefully you guys enjoyed it, and hopefully you guys can take advantage of some of these things to get some of your applications out into the cloud as well.